Hello and welcome. In this video, I'm going to show how to connect to Wi-Fi with a device running MicroPython. I will be using this board, the WebBit Lite, throughout this video. It has an ESP32 S2 chip on board and MicroPython flashed on it. Without further ado, let's get started. Okay, I've got the board connected. Let's jump over to my computer here. The editor I'm using is called Thonny. It is a great tool for beginners. It's free. I'll link it down in the description. My long-term goal for this project is to get this board running as a temperature monitoring device for my water heater. In order to make it online, the first step is to set up this board to connect to Wi-Fi. A quick search on the internet tells me that the network module is needed, so I'm going to import that first. That is import network. This enables the functions for the board to establish a connection. For more information regarding this module, I've also linked a document in the description if you wish to learn more about it. What I'm going to do next is set up this board as a station, specifically network dot wireless LAN, give it an argument network dot sta_if. The way to interpret this line is from the network module there is a wireless LAN function, and I'm going to pass it an argument setting it up as a station underscore interface. Next, I'm going to store all of this inside the Wi-Fi variable. And to do this is very easy. Just type Wi-Fi equals network, like so. So that way I could just call this Wi-Fi variable instead of retyping all of this. For example, I can activate this station by typing Wi-Fi dot active function and pass it an argument true. This acts like a power switch. This will activate the module for it to start searching. What we're missing now is the Wi-Fi credentials. For this, I'm going to use the connect function inside the network module. So to do that is Wi-Fi dot connect function. It has two parameters. The first one is your Wi-Fi ID. The second one is your password, like so. And I'm going to add a print function so that the computer tells me that when it's searching for a Wi-Fi. Like so. So that when the shell starts printing searching Wi-Fi, I would know the search has begun. So when the shell prints out searching Wi-Fi message, I would know the search has begun. I'm going to use my phone's Wi-Fi hotspot here. That way I would know when the board has connected or not. When the device has connected, this part will turn green, notifying me a board has connected. And now I'm going to change my Wi-Fi credentials to match my phone's so it can connect successfully. There. Now we can test out this code by running the current script. Whoops, you have to save this file first. Let's save it onto my computer first. Name it test.py. And click save. As you can see, the shell has printed out searching Wi-Fi, and my personal hotspot indicator has turned green, so that indicates the board has successfully connected to Wi-Fi. But if you don't have the phone to double check, you can use the isConnected function inside the network module to check if it's connected. That is Wi-Fi.isConnected function. And as you can see, it returns true, saying that the Wi-Fi has connected successfully. And that's pretty much the hard part finished. I'm going to add a few more lines of code that will give us feedback on whether it has connected or not. And we'll go over the complete code when we're back. Okay, a quick transition later. I've added quite a few things, mainly some simple feedback of the whole connection process. Let's start from the top. I added another active function, as you can see, set to false, because every time you reset the script, the Wi-Fi is still connected. If I wish to connect again, I will have to unplug and plug it in again. So by turning it off and on again, I will have a clean process every time, if that makes sense. Then a for loop right here of 10 seconds. As you can see, 1 second every cycle. You also need to add the uTime module. I've added a uTime module here for this, and this loop will break when the Wi-Fi has connected successfully, or when 10 seconds is up, when 10 seconds is up. So if the Wi-Fi is not connected, it will print eternal error. If it's connected, it will give me a message in the shell, Wi-Fi connection okay, and the current network config and the current network configuration. And I've bundled this whole process in a exception, so try an exception. So usually you use this type of usually you use exceptions in a part of the code where it is expected to fail. But in this case, it's just I just wanted to print out the messages from the console. I have my phone hotspot here ready. And let's test this script by pressing the run current script button, which is right here. Test. Okay, the green light is on and we are connected, and as you can see in the console, we have the full network configuration messages printed out in the console. Even though it's connected, we can still triple check by using the isConnected function. Wi-Fi.isConnected function. It returns true as expected because as we can see, it is already connected. I'm going to name this file, I'm going to save this file as Boot.py and save it onto the board. So I'm going to save as MicroPython device, Boot.py. What this does is that it makes this device automatically connect to the internet upon startup. Okay, let's reset the board. I'm going to stop the script. It's going to restart. Okay, as you can see, there are no messages printing out, but we can still check the Wi-Fi status by typing Wi-Fi is connected. So, oops, Wi-Fi.isConnected function. You see, returns true. So it is already connected during startup, but it doesn't print it. It will not print out anything because it is now a boot.py file. And that's it for this video. Thank you guys for watching. I'll see you guys next time when I use this board to play with MQTT.